Good morning friends. Today we are going to discuss KNN or K nearest neighbor machine learning algorithm. By its name, it appears to be a clustering algorithm, but unlike clustering algorithm, this is a supervised type machine learning, whereas usually clustering algorithms are unsupervised one. KNN is considered as supervised one because it requires classified datasets as training datasets, whereas unsupervised learners doesn't require any classification of data in training dataset. We call KNN as lazy learner because during its training phase, it doesn't do much except setting the value of k and storing classified training dataset inside its memory allocation. On the contrary, algorithms we have seen so far somewhere do much of analysis and iteration work during its training phase, and therefore they are called eager learners. In KNN, real iteration is performed during prediction time. During training phase, it also stores an integer value denoted by k, which signifies the number of nearest neighbors to be explored during prediction time. It can take any integer value like 4, 5, 6, etc. Its value is chosen carefully, taking overfitting and error into consideration. Overall process is, we feed training datasets which is already classified. We assign an optimal value of k. Classifier stores entire training dataset inside its memory and training phase is over. During prediction phase, we feed a test data point. Algorithm determines Euclidean distance between test data point and each of data points in training dataset which is already stored in memory. Euclidean distance is calculated as root over sum of squares of distances of each feature with respective features of test data point. Here squaring the distances prevents the positive differences to get cancelled out with -1. Classifier enlists k number of such data points for which Euclidean distance is least. We call them k nearest neighbors. Now majority of nearest neighbors belong to which class or cluster becomes the class of prediction dataset. For regression problem, we simply take mean of all k nearest neighbors as prediction value. Let's understand this with an example. Suppose we have 14 data points P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12, P13 and P14, and they are classified into 3 clusters or classes C1, C2 and C3. Now the moment we feed training data into classifier, it will store P1, P2 up to P14 inside its memory. Suppose P is a test data point for which we need to find suitable class or cluster. As a process of prediction, it will calculate Euclidean distance between P and each of training data points. Suppose D1, D2, D3 up to D14 are Euclidean distances for respective data points. Suppose k value is 5. Therefore, algorithm will find 5 least values among all distances. In our case, suppose D1, D2, D3, D11 and D12 are least 5 which belong to data points P1, P2, P3, P11 and P12. Since 3 of them belong to cluster 1 and 2 belong to cluster 3, so we will choose majority one which is cluster 1 or C1. Therefore, point P belong to cluster 1. In case of regression problem, we will consider mean value of 5 nearest neighbors. Here selection of k value and feature selection plays an important role in creating the model. Less key value causes overfitting and high k value causes underfitting. Also, if number of features are high, then it may cause overfitting. To avoid this, we should focus more and more on feature extraction and selection. As we can see, this algorithm is very simple, but this is very useful. In coming videos, we will discuss other classifiers. Till then, goodbye.